Today it's our second session for Learning Go with test-driven development. I'm going to go over a brief summary of what we have done in the first session. Basically, we have introduced the Go programming language's main functionalities, and we went over some presentation about which company is using the Go and in what scenarios they're using the Go. For the code, as you can see here, there's a test function in a file called hello_test.go. This is how Go understands that this is a test file. So this is kind of a rule that we need to follow when writing tests for the functions that we have. So as you can see, we have a hello.go, which includes the actual functions that we create, and the hello_test.go, which includes the test functions that we create. For the naming of the test functions, we have this prefix for every function that we are testing. So in this case, we are testing the hello function from the hello.go, which returns a string concatenated by the input parameter name. And here the signature of the function says to us, this is a function called hello. It takes a single argument called name, and it's a string type, and it also returns a string. So that's how the Go's, let's say, signature of the functions are working. And in the test function, we see that we are calling this function with the GTSC, and then we're expecting it to be this string here. So here we are basically preparing the test by having two variables: got, which is the actual result coming from the function, the want, which is the function, which is the expected value that we are expecting from the hello. And then here we're checking if got is not equal to the want, which means that something is wrong. We're calling the t.errorf function, and t is just an object coming from the testing framework, which is built-in framework of the Go. And as you can see, we're importing it here. And then we're saying, okay, we got this and want this. So here there's a string formatting happening. This is where Go actually gets the first input into this function and then injects it in this string, and the same goes for the want. Yeah. We will be seeing more formatting decorators, let's say, in this class. So for example, we are using a percentage Q. This means that, okay, inject my variable's value here and also add a quotation mark on each end, yeah? But there are many other more that we will be seeing, and you can also actually check it out from the Go's official documentation more about this. So for starters, I will be pasting some links to the chat for some reference. So this is the video link to the first session. If you missed that, and if you didn't find it anywhere else, you can go click in this link and watch it later if you want to go more deep dive into it. Also, if you don't have Go installed in your machine and you would like to follow through what we're doing here, you can also download it by the following link, which I'm trying to get. Just give me a sec. Yep, this is where you can install, and it has actually instructions based on your operating system. So if it's a Windows, once you click that blue button, there's a list of operating systems, and you will be able to see the installer for the Windows as well, yeah? And for more convenience, I will be updating a GitHub repository, which includes every code that we will be writing here every week. Let me get it from here. Okay. Yeah. So the GitHub repository link is on the chat as well. As I said, after the sessions on your own time, you can just check the code if you are having some struggle with something and your code is not working and you want to check what's wrong. You can also take a reference from here. Okay, for those who would like to follow through, you may not have this actual repository here, But you can actually clone the code from the GitHub. And once you have the Go installed on your machine, you will be able to run all of the commands that I will be running. But don't please feel yourself obliged to do that right now. It might take a bit. You can, as we're recording the session, you can actually watch it later and then go through them again. All right, so what I'm going to do is today, we're going to go through the integers in Go, and we'll be learning more about them together with the test-driven development concepts. So test-driven development is actually, in a sense, is to write the tests first rather than writing the functions first. Yeah, so basically you're going to see a bit more practical way right now when I'm trying to implement integers here. Okay, so for this, we're going to basically create a new directory in our repository called integers, okay? And once I do that, basically it will appear in my VS Code Explorer here as well. And I would like to add a new file here called the sum_test.go, okay? So at first it's gonna give some error lines, the red coloring everywhere, which means that we have to actually define a package for this file. And in Go, we actually have a convention, a guideline to follow. So each folder in Go should have their own package. Yeah. So if this folder is called integers, actually the VS Code will be telling me to name this whether integers or integers_test or main. Well, in this case, we already have a main package here, but I will be sharing a link. This is used sometimes in more complex applications to have like nested main packages. But I will give you a link where you can read more from the official Go team that they basically gave some advices and recommendations how to structure the Go project. So, but for now, we're going to go easy. We're going to just go with one direction. One directory is equal to one package. So we're going to go with the package integers. All right. So here we would like to call a test function. Yeah, we're going to write a test function first because we're doing test-driven development. As you can see, it also, the VS Code actually uses the IntelliSense in telling me, okay, I can actually do this, but you're going to replace the XXX on your own to have your own functions. So I'm going to call this function adder. So we're going to test the adder function. It's going to be taking the T object, as I was mentioning. And as you can see right now, it's saying, okay, undefined testing because I cannot see anything regarding to it. That's a compiler error. And in test-driven development, compiler errors are our best friends because they actually tell us what to do. So here, that means that we are missing something in regards of the testing. And what we're going to do is we're going to call import, and then I'm going to open this quotation mark. Once I do this and save the file, now everything should be fine. So basically what I'm doing here, I'm importing the testing package into this file to be used, yeah? Okay, once we do this, we're gonna basically set up our tests in this section. What we're gonna have is a variable called got, which will be returned from the actual add function that we would like to test. So we're going to write a function that will have a name add, and it's going to take two parameters, both integer, and then we will want 4 by return. Yeah. So when we are creating variables in Go, we use this syntax, a colon and an equal mark. This is the same exactly thing, writing, I don't know, some my text string. So this is also a variable initialization. Here, the myText will be having the default value of the string type, which is actually an empty string. But I could also say, okay, var myText is equal to TST, for example. But now it will not have the default value because I have declared that it will use a TST, yeah? All right, so once we have this, we're gonna call the plain old if condition. If God is not equal to 1, which means something is wrong, we're gonna call the t.error f function. We're gonna say got %d. So this is different than the previous one that we were using q. Q is for strings and d is for integers, basically. And we're going to say also got d, want d, and we're going to pass in the variables in the correct order, so everything will work fine, yeah? So we have all the test function right now. And as you can see, I have my integers package here as well. And in Go, in the previous session, we were just using go test dot command. So basically, go test command is receiving this dot as a direction to where to look for test files, yeah? But now that we have a nested folder here and a nested package, we have to pass in this special direction, yeah? That means go and check all of the files under each package or each folder, even nested ones, and then basically run the tests on this one, yeah? Also, on the test command, we have a argument that we can actually enable, a flag, which is -v. This comes from verbose, and verbose in software, usually for the command line tools, means for print a more detailed output for me, yeah? So right now I'm gonna run it. As you can see, we have some pass from test hello, and as you remember, this is from the actual hello.go file. Since we're running all of the tests, we all see them, yeah? And we have some fail from the learn go with tdd/integers. This is the package's path that is defined. So this is my main module, learn go with tdd, which is the actual project. And this is the package that we are actually trying to test right now. And also, as you can see, Go actually, the testing framework, is using caches. So since nothing has changed in the hello_test.go, it's using a cache, so it's actually running the test more fast. And as you can see, the execution time here is 0.00 seconds. So it actually used the cache. But we can also disable this with another argument to the go test command line, but that's a more advanced topic, so let's skip that for now. But here, what I'm interested in is here the message that I'm getting from subtest.go. On the 7th line, it says undefined add, which means that something doesn't exist actually. Well, that's true. In test-driven development, as we are writing tests first, we are actually going to write the test first, even though the function doesn't exist, and then we're gonna write the actual function. So I'm gonna create another file called sum.go. Here it will be as well package integers. And here I'm going to define that function actually. So for sake of speed, I will be using some autocomplete features from VS Code and the extensions that I have installed for the Go language, okay? As you can see, when I write an F, I have some multiple choices whether what I would like to insert as an autocompletion. I would like to do the function. So I'm going to add here the function add. And I'm going to say it's going to take 2 input parameters, both type of integer. And it's going to return an integer as well. And let's return for now 0, okay? And this is how we're actually moving on. So right now, I could have just written x plus y, but in test-driven development, you just have to write so much code that it will just resolve only this issue that you're getting at that exact moment. So right now, the problem was that there was no function called add. So I just resolved that by just adding a function with the correct signature, which means the parameter and parameter types and the return type, and also a return statement here with a default value of integers, which is 0. So this is the only thing that I'm resolving right now. Now, this might seem like a thing that might become an overhead management. Yeah, you're just writing only like, I don't know, a short bit of things at a time. But when you have actually complex examples, when you will have to write more complex functions, this is actually very helpful because it will give you problems to solve one by one rather than having multiple problems at once, which is kind of a bad thing from time to time. So as you can see, right now our compiler is not giving any errors because it's able to retrieve the add function from there. Therefore, I would like to run my test again with the same function. And here we got another fail and saying that, okay, we got 0, but we wanted actually 4. So that's the problem from actually coming from the function that we have written here. It's returning only a 0, which is not the ideal thing that we want. So what I'm going to do is, of course, I'm not going to write a return 4 here. That would be adding another step of, let's say, complexity. But actually, sometimes this is happening in the production environments, okay? What I mean is, of course, not someone is writing a hard-coded value here, but what can happen when I run this, as you can see, our tests are passing. But actually, that's a false positive, which means this test is creating a result that is not actually true, but it seems like true. That's because only about this want value. In the next sessions, I will be using some strategy called property-based testing, which will give us the ability to test for different results for a single function. Yeah. But for now, we're gonna just go and be good developers and just write actually x plus y. So now it actually will run again and it will pass, but now it's not a false positive, but it's actually a correct positive because we're actually using the input parameters that were passed in. One more let's say tip for you. When you have, let's say, 2 parameters or multiple parameters that will have the same type, you can actually omit this first type statement here. What Go will do, actually, it will apply this type to both of these parameters here. So everything will be correct and working fine anyways. You can actually use this, but if you like to use the other way around, it's fine. It just depends on your preferences, yeah? Okay. So we're about that. And in TTT, basically, we do this in this flow. Yeah, we write the first test without even writing the function. And then the compiler said that, okay, you're missing a function, no function such as add exists. And then we added a function to make the compiler happy. And then the test was failing because the expected and the gut value were incorrect. They were not matching. And then we wrote the exact, let's say, functionality that we're trying to test in the sum.go file. And then basically we made our test pass. So what now? What is the next step in the TD? Usually how it works is you basically write the test and the function, and then you do the refactor. Yeah. So we're at the refactoring stage here, but actually there is not much to refactor here because it's a really simple function that just gets 2 input parameters and then just returns by summing them up. But I would like to show, since we are at this moment, I would like to show another functionality of Go that is built in about the Go documentation. So here in Go, actually, you can write like documentation from the code itself. And there's a tool called GoDoc, which will use these comments above the functions and then document them automatically and create an HTML file, and then you can serve it on your local machine, or it can be also served in the Go's package library, which I will be as well sharing some examples from the actually production level libraries. But here, let's say this add function receives 2 integers and returns the sum of them. Okay, this is what this function does. We just basically documented this function. And also, what is also built in Go, we can create some examples for our functions to be shown in this documentation that will be automatically generated as well. And to do this, we have to use the test files as well. And to create an example function, we're going to write a function that will have a prefix of example. Okay, so the same as test, but we're just writing example add, and then no input parameter here. We're just going to write, okay, we got a sum of 1 and 5. And then we're going to call the FMT packages println. FMT stands for format. It's a built-in library of Go as well. Once I click enter, it will automatically import it up above, as you can see. And then I'm going to call the println function, which is printing to this std out, usually the terminals, the variable that we got, okay, the sum. And here I'm going to create a special comment saying output colon 6. So I just created this example, and once I run the correct CLI command from the Go doc, it will create this example and inject it in the packages documentation. So this is a very cool thing, because usually the documentations of software are being done in a hard-coded way in README files, markdown files of the, for example, we also have one in this repository. But the thing is, if you are building a big library with a lot of users, and if you're actually changing some of the parts of your code, sometimes you may forget to update the documentation itself. So if you actually create your documentations from the code, then basically the tools that the Go has will take care of all of this management of the updating the actual documentation. So that's actually a very valuable thing in production level software crafting. Okay, and I will also run this once again to show you what's the difference. As you can see, we have the example add function being run here as well. But if I were to remove this and then run it again, the function would compile, but the execution wouldn't be done. So it's actually to integrate it for you to save some time on your test if your example is taking some time to process, basically. But now that we have it, I'm going to call a command line. After a specific version of Go, I think it was something around 1.16, I'm not sure, GoDoc was removed from the actual Go's command line library that is built in. So you have to install this on your computer in a separate way. But it's not a big deal. Basically, it will also have some sort of installers. If you just write GoDoc install, you'll pretty much get it in a very straightforward way. Here I have it installed in my computer. I'm gonna write the command GoDoc, and I'm gonna say, okay, I would like to create the Go documentation in the HTTP port of 6060. Keep attention to this colon. If you don't define this colon here, it will give an error saying, okay, but you didn't actually specify the host, like you just gave me a port, not a whole thing. But when you do the colon and the port 6060, it will automatically put it in the local host, which I will be showing you right now. Yep. Some window management here. Okay, let me share this screen right away. Are you able to see a different page? That was a very quick answer. I didn't hear.
Yeah.
Okay, super. So here, what Go does, it created that documentation as a server on HTTP localhost 6060 port, as you can see here, and we're at the PKG endpoint right now. And here there's a lot of packages here coming from the standard library, as you can see. So for example, we have the archive. We can go to FMT, for example, because we were using that. And when I go to FMT, I can actually see the actual documentation of the standard library that we just used. So it implements a formatted input by output functionality with actually analogous to the C's printf and scanf. Because Go was actually, let's say, influenced by the C language. It was created in Google. At that time, they had a specific problems that they had to take care of, so they just implemented a new programming language. That's a very bold move, I would say, but it went quite well, and right now the community is quite huge and it's been used a lot for servers. And as you can see, we have some formatting words here. We used, for example, D, as you can see, for the integers. If you would like to print them based on base 10, you use the D. If you would like to do the binary option, which is base 2, you can also put on %B. You also have some Q for a double-quoted string safety escape with Go syntax, and so on and so forth. But what I wanted to show you is the actual package that we wrote now. And once we go down, it should reside under our module, which is the main package, Learn Go with TDD. And here we have the sub package here called integers that we just write, yeah? And when I open this, I see the index here, what kind of functions that this package actually exports, and what is the signature of them. I have even examples, and this is like a place where I can, when I click, I will be scrolled down, yeah? Since we have only one function, it doesn't do that. But when I click the example, as you can see, it automatically opened this place as well. So here we have this text coming from the comment that we have added. That's a very nice thing. So it receives two integers and returns the sum of them. And we have the example. And once we opened it up, we see that the example that we wrote to the test file, and we see what the output is. So this is very valuable thing in production level software, as I was saying, because when you have a documentation, you will have less questions and you will have more confidence in your users to use your program. Yeah. Okay. With that being done, I will go back and share my VS Code again. By the way, any questions so far?
Nope.
Okay, super. If you have, please feel free to interrupt me and we can take over. Oh yeah, I had also one thing to show you. Let me share the other screen again. So this was our local host, but now you're going to see actually a production level framework and its documentation. So we have the Gene package here, quite a cool name, I would say, and it's a web framework written in Go. And most of the, let's say, HTTP services that companies are building with Go, they're using Gin or Echo or Fiber. There are many of alternatives, but Gin is one of the fastest. And as you can see, this is how it looks when you actually document your code very well. And you see what kind of functions are being exported, what kind of types are being exported, and so on and so forth. For example, let's, I don't know, go to some maybe okay, I'm struggling to choose a function. But anyways, let's go to add param. So as you can see, when I click, I scroll down automatically and it shows a nice sidebar with the navigation things. And as you can see, these texts are also coming from the comments that are coming from the functions definition, actually. So once you have a huge library as this one, it's very important to have such, let's say, a dictionary, about documentation, so that it will help your users. Okay, so let's go back to VS Code. Okay. All right, so this was pretty much it about the integers. Do you have any questions?
So far, not.
All right, super. So we can actually jump into another one. So in the next section, we're going to go over iterations, which are the pillar of the software to do repeated actions and processing for multiple object items or actions. Yeah. So here we are going to create another folder called iteration. And then here I'm going to write a new file called repeat_test.go. Actually, to keep it also clean, since we have add here, I'm going to rename this to add_test.go and rename this to add.go as well. Okay. All right. So we have a new folder, which means that we're going to have a new package. We're starting with writing the package definition here, and then we are going to do some testing again. So one thing in Go, Go was developed purely for developer experience, which means to learn easily. Yeah, let's say not a big learn curve, and not a steep learning curve. So it will be easier for people to learn and to not make it confusing. Yeah, the syntaxes are actually also basic. Therefore, in Go, you have only a single reserved keyword, a statement to use for iterations, and that is for. So in Java, in C#, and in the other languages, you have, for example, while, also in Python. You have do until, for example, but in Go it's just for. So because actually, in theory, almost like 95% of the time you're using for in all of these languages. There are some, let's say, edge cases that you might make use of while and do until, but with for you can actually implement these. So that's why the creators of Go just included the for keyword as the iteration. Okay, to display that and to present that, we're going to write again a new test function because we're doing TDD. We're going to call this function the repeat, and it's going to take the T object from the testing library. It added another parenthesis that was not required. I'm going to save the file so that the automatic import will be done. Everything will be nice and dandy. Okay, so here we will be having the same setup here. Yep, we're going to declare a variable called got, and the value will be coming from a function called repeat. And we're going to pass into this function a string of a. And then here we're going to say, okay, I would like to turn this function to return a string of a being repeated 5 times. So 1, 2, 3, 4, 5. Okay. And here I'm going to say if God is not equal to want, we're going to call the error f function got q. We're using q to use for strings with the quotation marks, but want q. So we're going to pass in these values as well here. And yep, that should be it. So what do we do now? We're going to run our tests. As you can see, we have some passes and some fails, so that's kind of confusing for me, but I can see what the actual stuff has failed at the end of the output. It says the iteration package build has failed because the compiler is not aware of a function called repeat. But as far as I know, we can do actually test a specific package. So I would just pass this information, which is the folder path to the package that we have defined, and then I can just run the same test command with the v flag, and it will just run that package's test. So if it's something important for you, you can also do this way, but I always use the /dot syntax to be sure nothing is being broken when I'm writing something, because in production software, something might be integrated with another package. For example, iteration package can be used in integers, just an example. And then if you just then update the integers and update the test in integers, and if you run the test in the integers, I don't know, maybe something has broken because iteration was using the integers, and then you can guess the scenarios that can happen. So always run all of your tests in your project. That's my personal recommendation. Anyways, we see that here. The repeat is undefined. So, okay, what do? We do write a code only for making this compiler happy. Okay, we're going to write repeat.go, a file that exists in the iteration package, and the function itself will be here. It will take a input with a type of string, and it will return a string. Okay, and for now, we're going to return a empty string because that's the default value of a string type. Since we're going in steps, we do not cheat. We do not write the actual code. We just made the compiler happy. Everything is green right now. So we're going to write the test command again, run it. And then, okay, it will say to us what we actually need to do, because it says we got an empty string, but we wanted A repeated 5 times. Since that's the case, we can go and make our tests pass by writing the actual code. All right, so we need a variable to return here. And in Go, there's a functionality of named return variables. So if I were to say, put this in a parenthesis and say repeated, now this is a variable that is actually I can use in this function scope. So I can actually return the repeated here, okay? But what I could do also, instead of doing that, I could just say, I will have a variable called repeated with a type of string, which will initially set to an empty string, and then I can use that as well. Using which, either way, it depends on your preferences and also in the function's context. So if it's obvious that this function will do only return a repeated value, so you can use actually the other way that we were just doing. Let's do that for now, okay? Because it's quite a simple function and everything is actually obvious. And when you have a named variable like here, you don't have to specify a return variable here. As you can see, nothing is being redlined here because the compiler actually understands this is the value that will be returned. So everything that will be processed in this variable, it will be passed into this return statement. So you don't have to write again repeated here, okay? If you would like to, you can, but you don't have to. So let's keep it as this now. Let's just return with a simple return statement without the repeated variable. Yeah, for the test to pass, what we want to actually to get this repeated string to be a 5 times repeated input that we have retrieved. So we're going to write a for statement here. Here we're going to have a variable initialization for I is equal to 0. So that's actually something very similar to other languages, but there's only one difference I will be explaining now. So I should be basically lower than the 5. So run this for statement until I hits 4, which is 5 times since the I is initialized with 0. And here we're going to have the I++. And then I'm going to open the parentheses, these squiggly brackets. Here, the main thing that is missing from the other programming languages is the actual parenthesis that covers these, let's say, statements, and the group of statements. In Go, you don't need them. It also applies to if statements, as you remember from here. You don't put any parentheses here. You just go through what you would like to put the condition statements or the variable initialization and the conditional statements for the 4 ranges. Yeah. So once we have that, whatever I will write into this for loop, it will be done for 5 times. So what I'm going to write is I'm going to set this repeated string, repeated plus input, which will make this function, the repeated variable, added to itself every time that it will run. And since that's it, we're going to run the test again, and everything is working. Yeah, we have the function, the test function passing, so everything is correct. Well, now that the tests are passing, we are at the next stage, which is the refactor stage. For sure, we can refactor this much, much better. So let's go with a simple refactor, okay? Right now, we're using a magic number here. So magic numbers are actually values in your code that you have hard-coded, so, and not put in a variable, yeah? So this is a straightforward 5 here, and this might be actually dangerous for many reasons. That's why you should not use these in your code. And what I will do is I will just define a constant variable here, okay? And this is something that we'll be learning new as well. And we're going to call this repeat count, and it's going to equal to 5. Instead of using this magic number here, I'm going to use the constant variable here, so that, I don't know, in the future a requirement has changed and the repeat count should be 10, I could just update here instead of the whole, let's say, file if it had this magic number all over the place. Since we have that, we can also introduce another operator called the concatenation or addition. This can be used in strings. It can be used in integers. We have this operator in other programming languages as well, if you're familiar with them. So it should be something not very, let's say, different for you. And once we write that and we run the test again, it should be passed again. So we did some sort of a refactoring. The thing is, maybe if you know, and if you did some lead code regarding the big O times for the time complexity and for the space complexity, sometimes string concatenation may, let's say, result in some memory overloading and that kind of stuff. Yeah. So to handle the memory usage of your application, of your functions efficiently, there are some, let's say, special functions that are provided by programming languages, string libraries, built-in libraries. And this also applies for C#, for example, or for Java as well. And you have in Go too. We can check that later, but basically to do a string concatenation like this in a for loop is not the best idea, because sometimes these string variables are being repeatedly copied in the registry of your registries of your RAM, and then it could basically, it's not very efficient in terms of space complexity for application. So you can actually use these, let's say, improvised built-in libraries functions which handles these. So as I believe, we have a strings package here, and we should have a strings builder. Yep, as you can see. And here we can actually call this var sp is equal to string builder. A string builder is, I think they have it in every programming language, as far as I know. They can be used to build strings, literally. That's what their job is. And with the string here, you can actually write this, let's say, some text into the string builder right here on the, let's go define it here actually. Let me take this up here. Oops, yep. And then here, instead of actually changing the variable itself, I will write to the string builder a string of the input, okay? And then on the return section, I'm gonna delete this repeated variable here because we're gonna use something special. We're gonna sp.string, which will what do? String builder will use its own efficient ways to handle the memory, and it will, at each iteration, it will write this input string to its own, let's say, handled memory. And then at the end, we're gonna get all of these values that were used and then convert it to a string. And then we will be having the same result as far as I know. Yeah, as you can see, it passes. Can it be done like string times int in Python? I'm not sure what you were talking about. Probably I don't know what this functionality in Python is. Would you like to explain it, Vladimir? I'm happy to hear that. Okay, I see. Never tried that actually, but we can try right now. Yep. Let's comment this out. Let's say return input. Probably will give a compiler error, by the way. Yeah. So invalid operation, mismatch type string, and untyped integer. So basically, you can only do this operation this time. But there might be, I don't know, strings that, I don't know, times or repeat. Yeah, as you can see, there's actually a built-in functionality coming from the strings package that actually does the exact same thing. So we can just give the input and the repeat count here. And if we run the tests, it will pass. But we're writing our own function, so let's use the sp.string. Actually, for sake of one other thing that I would like to show, let's do something else, okay? Let's go back to the repeated concatenation with here. So this should still be passing, all right? What I'm gonna do is I'm gonna write another function called repeat with sp, which stands for string builder. The signature will be the same, okay? It's going to return a string, but this time, instead of using the for loop and the string concatenation, let's use the actual sp here, which is the strings builder. And we're going to write a for let's use the auto-completion for this one. Okay, I is equal to 0. I is smaller than the p count, I++. We're going to sp.write string. As you can see, you can also write runes and bytes. Runes are basically characters in Go, but you can also write bytes if you would like to, but we're going to write the string, which will be the input itself. And then we're going to return the sp.string. Now, the reason why I did this, I would like to compare these two functions with Go's another built-in functionality, which is very nice. And we will be seeing that now, actually. So to do this, we go to the test file again. Okay, we don't need to test the repeat with sp file here once again, because it basically does the same thing. But just for sake of completeness, I will just repeat this, copy and paste this code here. And then we're going to call repeat with sp. And when I run the tests again, it should run both of them and it should pass, okay? But here we're going to have a different type of test, which is called a benchmark. So a benchmark is a way of calculating, or let's say measuring, the efficiency of your program. So how fast it can actually run, how many operations that it can do in a certain interval, and how efficient it is in terms of the memory usage, for example. So we can actually do all of these by writing a benchmark test. Here, since I'm using the Go extensions, I can actually write B, and then it will show me the IntelliSense completion, the snippet for benchmark function, and I will just use that. Basically, as the other test functions, you have the prefix benchmark, and then you're gonna write repeat, for example, because that was the first function that we wrote. And here we have a special for statement here, and also keep attention to this line. Instead of actually getting the, let's say, T object from testing, it gets the B object. So this is something used for benchmark specifically, and it has some special properties and methods used for benchmark testing. So for this, that's why we're using the B. And as you can see, this for loop will be run b.n times. So this n is actually the amount of times that your function will be ran by the testing framework of Go. And it is defined by the testing framework automatically by basically analyzing your function. And it finds a very good value to run this function, basically for giving decent measurement results. That's very handy, so that you don't have to actually specify what kind of times you have to run, but that's what's something you can actually do as well. You can tell to Go that you would like to run these tests this many times, etc. Okay, so for here, let's call the repeat function. Okay, what we're gonna do is we're basically just gonna call the function. Okay, we're not expecting anything at all here. No like God want kind of thing. We're just running the repeat function in this for loop. So once we have that, to run the bench tests, we will be specifying another flag that is specifically for this. And it goes like so, bench equals dot. If you're on a Windows machine, please don't forget to put these quotation marks here, or otherwise it won't work. But probably I need to also pass in the dot slash dot dot dot, but let's just see how it will work out now. Okay, it didn't do what I wanted it to do, so let's do that way. I think it was like this, probably. Yeah, okay. Sorry for that. Basically, as you can see here, the way to run the benchmark tests are through this command. So you specify the dot anyways with the quotation marks in Windows. If you're using PowerShell, Go test and -v is still there. And then at the end, you should specify the directory structure so that it will go nested folders to run the actual benchmarks. In this case, it was not able to find the bench test, so it was just running the actual test hello tests here, but that's not what we wanted. Okay, so here we see that this test repeat got actually into the benchmark. And here we have some additional information. So this is the operating system. Since I'm using a Mac OS, it shows as a Darwin. It's and here the architecture AMD 64 because my MacBook is an M1 chip. Therefore, it's not like Intel or something like this, or the x86-bitters, etc. Here we have the package, so which package the benchmark is coming from. We have the CPU, and we have the benchmark repeat title. And then here we have a result, okay? And here it says this big number is the actual b.n. So this is the amount of time that this benchmark was run. And then it made the actual measurement averages and calculations. And it says, okay, your function runs in average in around 153 nanoseconds. So basically, that's what kind of a, let's say, result that we can get. But to do actual, let's say, comparison, we have to write another benchmark function for the string builder. And here I'm going to run, not this one, sorry. with the different function that we built with the string builder, okay? So let's see if there are any differences in terms of speed. Also, we are able to see the space usage, which is the memory usage of our functions. I will have to look at what was the flag for that, but give me a 1 sec. Let's see what is the difference between the... Okay, even there's a significant difference with the string builder. As you can see, the function that we wrote with the, like, let's say, standard for iterations takes 137 nanoseconds, while string builder itself takes 46 nanoseconds. So here the string concatenation apparently taking some time to handle the memory management in order to get the values from the register, etc. As you can see, that's a completely, let's say, better result with the string builder. So that's very nice thing, because this will help us to write our functions faster and make us aware of our functions, how much they're fast, and you can actually present these in a, let's say, human-friendly way to your, I don't know, product owners, your stakeholders, so that, okay, there was a function like this, it was this fast, but we made it this percentage much faster. That's a very nice thing as a developer. Okay. We are at 1 hour. I'm going to ask, would you like to take a break? What about you, folks? Vanessa, Dimitri, Montaro. Okay. Seems like everything is fine. Give me 2 minutes, though, to refresh my water, and we can continue after that, okay? Super. See you. Okay, I'm back. Thank you for waiting. Let's actually check the benchmarks memory flag. Okay, there is an additional flag that we have to pass in. The construction of the benchmark function, of course, yeah. So basically, what you do, you have a prefix again called benchmark, like we had in test functions. And then you pass in the function name that you're going to use inside your benchmark function. And instead of putting the input parameter as t testing.t, you put the b testing.b. But also, please don't forget this asterisk or the star symbol, because that's actually a pointer. And this is a bit more advanced level of topic we will be getting to in the future, most likely. But it needs to be there. And here you will have a for loop. And this for loop will have a I variable with the value to be initialized with 0. And then here, the conditional statement of this for loop to run is it should be based on this b.n variable, which will be defined by the testing framework, as I said. And then it's just the I++, and then you just call the function that you would like to benchmark, yeah? That's it. Is it clear now? Okay, so this B is actually like a, let's say, an object with some helper methods and properties. So as you can see, here we're using the end property, okay? This is a field in testing B structure. We can actually go to the definition of this. So as you can see, this is a, okay, that's not very, I'm not sure how it looks right now, but let's also close this one, maybe a bit like this. Okay. As you can see, this is a struct, and struct means actually like a class, okay? Well, we didn't really go into, I don't want to say object-oriented programming, because Go doesn't do actually completely object-oriented programming, but you do have some sort of, let's say, functionalities that can be related with those. But you can see this B as an object itself, okay? For example, a car has some wheels, has some, I don't know, it has a color, for example, a model, a brand, etc., etc. So that's what actually the struct is. So a B is some object that has some properties, and some these properties can be type of integer, time duration, function, and so on and so forth. And also you can define actually functions on this object in this signature. But this will make your mind more confused, I would say, because again, this is something a more advanced topic. But this is just a helper object that we use in our test files. And for example, here we're using the n field here, okay? And that means to run this function n many times, and this is being automatically set by the framework. And for example, another example for the testing.t object, okay, this is the t. We are using the t object's errorf function, which is used for printing out to the terminal what has actually went wrong in a nice formatted way. And it has some different kind of functionalities, let's say functions and some fields as well. But right now we're going simple, and we're going just using some of them, let's say the fundamentals only, to make it simple. Do you have any other questions, or is it clear right now? No. That asterisk is something called pointer. Again, it's another advanced topic. But let's say, in a simple way, it instructs the program to use only a single instance of that object, and only that single object, okay? So for example, let's say there are multiple cars, but we want only one of them. That was not a good example probably, but we'll be getting it to it in the future sessions. But don't get confused by it. It's just the instruction to give the program to just specifically get some specific instance of that structure. Yeah. Okay, super. I, by the way, got how to actually also check the memory usage, because we see only here in the benchmark the time complexity, which means how fast our functions were. But we can also check the space complexity, which will check how efficient our functions in terms of memory management. And we're going to do that by passing in this flag -bench mem. I'm going to run it. It's going to run it again, but this time it will have a different output. And I have to probably make this a bit bigger. Yeah, as you can see, here we have 8 bytes per operator with the string builder, and 16 bytes per operator. I'm not sure if this is byte or bit, but we can check. But as you can see, the measurements are much higher in the one that we just used a string concatenation as so. Okay, that's why it's always better to use the string builders in every programming language if you have to build a string or concatenate a string. Super. I'm very glad that we have actually went over this, because it's quite a nice feature in Go, and it actually gives us more confidence, as I was saying. Okay, so let's do some practices over the repeat function. And I would like to do this with the existing function we have here, test repeat with sp. Okay, I'm gonna keep the repeat with sp as so. And here we're going to say, give me a 1 sec. All right, so let's give this function another feature, another additional shiny feature. Since we right now are repeating the input character, sorry, the input string 5 times, let's say that we would like to actually define that repeat count on our own while calling this function. So let's say, okay, this function will take also an integer to define, let's actually do 6, to define how many times I would like to repeat the string that I have passed in. And again, we're going to go with go test v. Something is failing because the build is failed because too many arguments in call to repeat with sp. So what this is again another compiler error. And what we have to do is we have to fix this function to accept 2 parameters, 2 arguments, instead of 1. We go to repeat with sp function here on our repeat.go file. We're going to say repeat count. It's going to be integer. And then actually here, the repeat count here and there is kind of collapsing. Let's see what will happen. I've never had this scenario, but we should get 6 of them instead of 5. So let's also update the want section. Oh, yeah. Yep, 6. Let's run. We have a failed. Oh yeah, because we actually forgot this one. As you can see, when you are doing test-driven development, you are realizing your bugs in your code. So as you can see, I forgot to add another integer argument here in the benchmark function. Whether it's a test or benchmark, the compiler will say you're calling this function in a wrong way, so you have to fix it. Okay, hopefully that's everything. Okay, so everything is running correctly right now because in the test function we said we would like to pass in a parameter, additional parameter argument called basically repeat count, but the value is 6 here, and we wanted this function to return actually 6 times of repeated string that we have passed in. So everything seems correct. Just for being safe, I'm not going to remove this because probably there's a scoping here that this one is actually being used exactly from the variable itself, and this one is used from the constant itself. So there's the scoping happening, even though they have the same variable names, it's not overlapping with each other. So I'm going to keep it there because otherwise, if I delete this, I have to put a magic number here, which I don't want to, and I don't want to also remove this repeat function because I think it's also important to see the benchmarks. Okay, so what we can do, we can, for example, do some documentation more. That's a practice. Are you able to hear me now? Because my microphone just died, I think. Okay, sorry for that. I don't know why, but my phone got disconnected, but I think it's okay now. Okay, let's do some documentation. Let's say receives a string input and returns it by repeating it 5 times. We can actually probably also define that repeat count times. I don't know how it will actually react to this, but let's say repeat count times. because we should be able to see this in the documentation as well, this constant value. And here, let's also add uses string concatenation with plus equal operator. Let's say let's use a string input and a repeat count, an integer repeat count, and returns the repeated input repeat count times. Okay, let's also add uses strings.builder for more efficient processing. Okay, let's also maybe add an example. Probably we can add these at the end. Example, repeat with SB. It takes nothing. We just call the function by assigning it to a variable called repeated. Repeat with SB. We're going to put, let's say, AB this time, okay? It's going to be 2 times. And we're going to call the FMT, which is the format package, with its println function with the repeated, and the output will be in a comment as so, and it should be AB, AB, because it repeats that string 2 times, so it should be like this. Also, let's add an example for the plain repeat function. We're going to have another repeated variable here with the repeat function itself. That's going to be A. And remember, it was using the constant variable, and that's going to be 5 times. So we're going to just write the repeated here, but the output will be this time. Actually, just for sake of being more complete with the other examples, let's put AB, and this should give us 5 times of AB. So 1, 2, 3, 4, and 5. Is there any way not to set the numbers repetitions, but to analyze the want variable and automatically set the repeat count variable based on that? Or does that seem like over-engineering? Okay, you mean this, right? Wait a second. I want to see if I understood your stuff. So basically, we would have the want variable on the first line as so, and then you would analyze somehow the want variable, like repeat count would be, and then I don't know, something like this, and the want. So analyze this want variable and then just return it the count of repeated times. This would be over-engineering, you're right, because for this we had to write another function which has to have an algorithm to basically understand how many times a string was repeated. And also we have to know the pattern of the actual string. For a single letter, this is very correct because it's repeated the same thing. But if we had, for example, AB, 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 or ABC, 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 how would your analyze function would know that pattern so that it could actually separates them and then counts this, let's say, separation and then returns that. So that's, I would say that's an over-engineering, and I would say that's actually not a very trivial thing to solve. I'm sure that there is some sort of a lead code question like this, but yeah, I would say we don't do this. In your test, you have to be more let's say, specific. When we get to the property-based testing, we will be having, let's say, objects, okay? And these objects will be used for inputs to the test functions. When we have that, it will be even more descriptive, because actually our tests are the documentation of our software. Because when you go to a software, I don't know, some repository on GitHub, and you go to the test of this repository, you can actually see what is expected with which input. And this will actually help you how the actual software will run. So it's always better to be as descriptive as much as you can when you're writing tests, I would say. Any questions? Okay. So since we have the example functions, we can actually write the go command. Let's run this in 6060 port again. I will share my screen. Okay. Here, let's go down. I think I missed it. Oh, yeah, here. Learn Go with TDD iteration. Yeah, as you can see now in the index, we have two functions because we have documented two of them, repeat and repeat with SP. And when we go to repeat, retrieves a string input and returns it by repeating it repeat count times. And actually, we don't have the constant value here, but I'm sure if we would add some comment on that constant, it would also add here. We can try that. And we also have the repeat with SP function, and it has also this other comment that we have presented. As you can see, the examples are also working just fine. I would like to try really fast if I could get that constant used in repeat function for repeat count. Okay, let me run the command again. I know you can see my screen right now in VS Code, but that's intended. I'm just gonna refresh. I don't see any constants here. Probably there's another way to document this constant. We can check offline. I don't want to go deep dive into this rabbit hole, it seems like, but anyways, it may be a good research homework for you to check how you can actually also document some constant variables in your files. Okay, let's go back to VS Code. Okay, are you tired or you would like to continue? If you're tired or if you're enough, we can end it. I know people have only such amount of attention span. Okay, I'm getting continues and I'm good. Okay, super. What about others? Vanessa, Vladimir, Montaro, you folks are good? You're kind of okay. That's nice to hear. Okay, then yes, we will be going to more advanced example. Maybe not so advanced, but let's go into the next topic, arrays and slices, okay? Super. Give me 1 second. I have to manage my windows again for this to work correctly. Tell me if you can see again. Okay, super. So we're gonna have some new folders. And it's gonna be called arrays and slices. I'm gonna use kebab case here, basically dashes between the words. And we're gonna have a new file called, this time sum, test.go. It's gonna have the package arrays and slices, and also keep in mind in your package namings, you cannot have any non-alphabetic characters. So it should be ASO, it's okay. Go compiler actually understands that it actually belongs to this arrays and slices folder. So we write it in this way. We're gonna write another test function. I'm gonna use the IntelliSense snippet to be more fast. We're gonna write a test sum here. Okay, when you do the GoDoc thing for a couple of variations of your test, let's say, does it like overwrite the documentation file or creates a new one? So basically, in order to update the local version of your GoDoc, which is on the 6060 port that we were checking, I needed to kill the server, because when you run actually GoDoc, let me also share that in a second. When I run the GoDoc, it starts a process and runs a server on my 6060 port, or the port that you will give it. And to basically refresh it, I have to kill it and then do the, let's say, updates on the examples, etc., and then rerun it again. Does that, okay, super. All right, let's go to the test function again. We're gonna have a function called sum. We're gonna have dot sum. Let's skip the argument part for now, but we can have want. Let's say 15. If God is not equal to want, we're gonna say t.errorf. Also save it so it will give us IntelliSense from the test package. We're gonna say got d, because we're using integers. Want d is gonna be as so. All right, so this function should retrieve an array. GoDoc does not work for me for some reason. Okay, did you install the GoDoc? Because it does not come pre-installed with Go 1.21.4, which is in the link that I have sent. Okay, I will send you how to install it in the chat actually. So you actually install the GoDoc by using Go. So if you run this command that I sent to you, it will install this GoDoc tool with the latest version in your computer. And then you just close the terminal and open a new one to refresh the terminal, basically. It should be working. Okay. Will there be a list of links somewhere to find them after the workshop? I will be sending them. They're already in my Notion notes. Probably in PDF format. Any questions?
No.
Yeah, Misha, actually, that's a good idea. I'll definitely do that. Okay, maybe I can even make this Notion file public and add that link. I don't know. We'll see about that. All right. So here we need to pass in this sum, an array of integers, so that what I want to do in this sum function to do is basically, I would like to pass in an array of integers and get the sum of these array of integers. Okay, this is what I want to do. So it needs an array of integers. Therefore, I would like to define one. So we're going to say numbers are equal. We're going to define a variable called numbers. And how to define an array. So we write this squared brackets, very obvious from other programming languages if you know them. And now I'm going to put a number here, which means the length and the capacity of this array, okay? And then I'm going to put the type of the values that this array will hold, which will be integer. And then I'm going to actually declare the variables, the values that exist in this array. So I'm going to open squiggly brackets, and then I'm going to pass, 1, 2, 3, 4, and 5, okay? And you do the math, basically, that gives us 15. That's why the font is 15. And here, a difference between arrays and slices, which we will get soon enough. But I want to show one thing. If I wanted to add one more, as you can see right now, the compiler says, what the hell are you doing? Because it says index is 5. Index 5 is out of bounds, which is bigger than the bigger or equal than the 5. Since I have declared this array as a 5-membered array, I cannot put more than 5 members here. And I actually tried to do that, and the compiler will give me an error. So that's the, let's say, the most important thing about arrays. Okay, they're limited based on the end value that we're giving it in this section. Okay, or you can actually also define arrays with this way. Okay. And here I'm actually free to do so, whatever I want, because this will instruct the compiler to set this integer arrays, let's say, capacity and length based on the members that I have defined here. But this is specifically for the initialization. So, which means that initialization means here to declare the variables, the values, sorry, that the array will hold. Okay. But for sake of simplicity, I'm going to use the 5 version, and I could get the compiler errors. So, okay, we have a question. And if I want to mix values, let's say 1, 2, hello. Hello is a string, and 3 and 4. You can't do that. You can't do, so Go is a strictly typed programming language. You cannot have, let's say, multiple types of array, as far as I know, if something didn't change in the programming, the Go's own standardization. But you can't basically have, like, I don't know, something like this, okay? It will actually give a compiler error because you cannot use this untyped string constant as an integer value. And there, as far as I know, there's also no other way to define like multiple typed arrays. Okay. So we have the numbers array, and I want this numbers array to be used in the sum function. So now that everything is done, you know the drill, we run the tests. And here we have a fail from, okay, why did they fail though? This is undefined sum from arrays and slices, that's okay. Why do we have something from test example repeat is my question. Got AB, want AB. Okay. It's coming from example. Sorry. I know what's wrong. because in the iteration, in this example, I put the output as this way, but it should be without the quotation marks. Sorry about that. Okay, now they're passing, but we are only failing on the iteration, the arrays and slices, because the sum function is not defined. So let's do that. Sum.go, package arrays and slices, a function declaration with sum. It's gonna get numbers argument, and the type should be. Now here's the funny part, because in Go, arrays types are also, let's say, encoded with the number of length. What I mean is a 4-membered array of integer is not equal to a 5-membered array of integer in terms of type, because Go actually combines the capacity of the array that you have defined. In our case, it was 5, and it kind of combines that member count and the, let's say, value type. So integer 5, and that comes a 5 integer, yeah? So I can actually say here, let's say 4 integer, okay? This means this sum function accepts an array of 4-membered integer. And when I go to Subtest here you will get a compiler error because cannot use numbers variable of type 5 integer. You see, it's not just an integer array, it's an integer of 5 members. And as 4 integer members of array. So it's not they're not matching. That's why if you're using an array for some reason, you have to be sure that you're using the same number of members when you're calling, okay? And this sum function should return an integer, and as a value, we're gonna return the 0, and here we're gonna test it out. So we have another fail because we got 0, as you can see, but we wanted 15, but at least we got rid of the compiler error. So we go back to the test, and what we are going to do is we're going to actually implement the function itself, and so that we can make the test pass. Okay, we're going to do some nice thing here. I will be showing you 2 ways of handling this problem. So basically, we're going to have a variable called sum starting with 0. We're going to have a for loop starting with I0, and then the count should be numbers dot. Sorry, not dot length. In Go, you can get the length of the arrays with a special function called len, and then you just pass in the array that you would like to get. Okay, so this will return us actually 5. And here I++ stays the same. And then what we're going to do is sum is equal, add to the sum the value that we are currently in the current iteration. How we can get that? We can use indexing. Go supports indexing. So we're going to pass the I, pretty trivial challenge, and we're going to just return the sum. Okay. So basically what this loop will do, it will go all over the numbers, it will add it up to the sum, and then it will return the sum. Exactly what we wanted. So let's run the tests again, see if it's passing. Everything passed, as you can see. Yeah, we can also see it in the arrays and slices package. So that's a good thing. But I want to show another for iteration, especially in this one, because it might be useful. We have a different type of for loops, okay, without using the, let's say, the conventional way. Here, instead of writing this for, if you have the correct, let's say, extensions installed in the VS Code, you might get this IntelliSense as well, like snippet with double R. But if you don't, I'm gonna wrong anyways. So we're gonna write F4 as a normal thing, and here I'm gonna write index, comma, number, and then I'm gonna open. Let's say put this variable declaration operator, and then I'm gonna say numbers. Okay. Sorry, not numbers. I also put range here, and then open it. Okay. What this does, on each iteration, it defines two values, okay? Index and number. And as you can see, this comma actually helps us to form that structure. And the first variable is always the index that the current iteration is. So that starts with 0, goes 1, 2, 3, 4, 5, etc. And the number is the actual value inside the numbers in that index. So it's quite useful. Instead of writing the indexing strategy like numbers, square brackets, I, you can actually just use the number itself. And if you don't need the index for some reason, you can just put an underscore and it will disable it in a, let's say, compiler-friendly way. So you don't have to worry about that. And what you want to do here is, which I think this is very readable, sum, add the number, okay? Just range over the numbers, put the number in the current iteration to the number variable, and add that number to the sum variable, and then just return that. If I run the test again, everything passes. This is a very, you could make it a similar example. You can relate it to the for each statements in other programming languages, for example. Did you like this one more than the other one? What's your opinion? Yes, I could. I will comment this out, don't worry. Okay, we don't have number. So numbers and the indexing with the I. That's how basically it looks.
Could you explain the one with index again?
Yeah. So basically here we have the, let's say, basic for loop, okay? We initialize the I value as the 0, and then we have a semicolon to make the other, let's say, declaration in terms of the condition of the loop to continue, and also what operation will be done on the index itself. So the left part is the initialization part, and then on the middle part, you check whether index is smaller than the length of the numbers, so that you are still in the numbers range and you didn't go over. And then on the last part, you just do this operation at the end of every iteration. So at the end of every processing of sum plus sum addition with numbers, you increment the index to go to the other item. And here, what we're doing is we're actually adding the value inside the current index, which is the I. And we're getting that value from the numbers array, which is coming from the input. But on the first one, we are ranging over the numbers. And then here we declare two variables. Okay, it's possible to declare them. And here we can actually discard the value that we don't need. So this could be also for number, okay? I could just discard, I don't know, the value part, and then I could just get the index and just do something on the index. So, but now I don't need the index because I'm just interested in what values are coming in from the numbers so that I can actually add it to the sum. And then I'm discarding the index, that's why, and I'm just getting the value in the second part after the column here. comma, sorry, and then I'm using that value to add it up on the sum. But I will keep this commented out here. I see that on the chat, everyone favors the range version. Range looks more clear. I completely agree. It's much more readable, and you can actually, I don't know, do more kind of nicer stuff. When you have nested loops, for example, it's even better. Like, because imagine if you're writing nested loops with the conventional way, you have these like for I, J, K, blah, 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 and then you're just like out of the world. You're like, what the hell am I reading? So you can actually do more better nested loops with the ranging as well. That's my personal thoughts. That's the for each. Literally, this is the for each of the Go. Yeah. So for each number in numbers, you can think of that way. Yeah. Just the syntax is a bit different. Okay. Any questions? Okay, super. Now we're going to do some different stuff. Now I'm going to show another functionality of this T object that we were discussing before. So in a single test function, we can actually run multiple tests. And to show that, because we're going to use that in the future, I'm going to call a special function from T object called run. Okay. And you can see the documentation here. It takes a name, a string argument, and it takes a function with the exact similar signature as we have here. And it's F for some reason. And then we have the return value bool. Okay. So it checks whether the tests have passed or not with the bool variable. As you can see, it says the run function runs the F, the function that we define, as a subtest of T called name. Okay. It runs the F in a separate Go routine and blocks until F returns or calls T.parallel to become a parallel test. And run also reports whether F succeeded or it at least did not fail before calling T.parallel. So Go routine is also an advanced topic, but it's actually a very nice topic and one of the, let's say, prime features of Go. And it's simply put, very hard to do it, but it's simply put something used for concurrency to use efficient, let's say, hardware usage of your host machines, of your computers, etc., etc. Okay, but we'll get to that later. Okay, but I'm going to use the T.run, and I'm going to write here collection of 5 numbers. Okay, this is the name of my test that I would like to do. And here there's a very nice thing that VS Code does with the Go extension installed. When I write func, since it knows that this second argument is going to be a function and it knows the signature, as you can see, it says it takes a T argument with the testing.T struct, it actually provides me this auto-completion as well on the first line. And when I call enter, it will automatically put that signature there. And I'm going to open this function. And what I want to do is I want to get all of this there. Okay. So I'm going to run this previous test that I wrote as a subtest inside this test sum. Okay. And you may ask, why the hell are we doing this? Like, why do we have subtests at all? And this is used especially in the property-based testing, meaning that, let's say, giving different inputs into the same function, okay? And because different inputs may be result in different outputs. For example, what I'm going to do is I'm going to run another T.run function here. And here we're going to use some new thing that we're going to learn about now, which is slices. And here we're going to say, looks like the same like describe and it ingest. Exactly. That's a very nice point, Dimitra. That's how it looks like. That's what I was actually thinking about when I first saw about it. But it's very quite nice because it also formats the output in a very nice way we will be seeing now. So yeah, this subset will run the sum function of a collection of any size. We're going to have the actual same function signature here. I'm going to open that function, and here I'm going to define numbers again, but with a different syntax here. 1, 2, 3. Okay. And I will have a want of 6 because it's a different type of members and values here, because the sum of all of these values are 6. I want that. And if God is not equal to want, we're going to call. As you can see, since I have access to the T coming from this function that is nested inside the T run, I can use error F or any other variable coming from the testing T struct. I'm going to say got D want D. I forgot to call the function. Here we're going to pass in the numbers. Okay, now you can see what the VS Code is doing actually, which I don't want him to do. It tried to explicitly cast this numbers variable that we just created into a type of integer array with 5 members, because it knows that this function accepts only this type, and we know that the Go actually encodes the length of the arrays into the type itself. That's why it was trying to actually, when I save, okay, now it didn't work, but when I was writing it, it was trying to explicitly cast into it by writing this. I will show you now. This specific, let's say, syntax, okay? So here's how you basically explicitly cast some variables into other types. You put the type, and then you open in parentheses, and you put the variable inside there. But that's not what we want, because I want this to be actually fail. Okay, now I'm going to write get test v again. We have a fail at the end. As you can see, when I go up, I have the compilation error. Cannot use numbers variable of type int as 5 int value in argument to sum. Because, my friends, this is not an array, this is a slice. And the difference between arrays and slice is that arrays have a limited number of members, which you can define at the initialization, as you can see here, like 5, or with the ... version that I was showing, and it automatically, the compiler automatically gets the number of members you put in this squiggly brackets, and then it puts it there for the type, but this is the type of array, yeah? But when you don't have any, let's say, specific length or capacity integer inside this square brackets, now this is a slice. So as you can see, slices are used, I would say 99% of your time, you will be using slices for working with collection of some objects or some values. So slice is like just a list in Go, exactly. So in C# we have the collection.list, a list. In Python, I also believe that we have a list. I'm not sure of the name. And basically, slice is a list, and we with what lists are providing us, like also in other programming languages, it provides us the dynamic behavior of the length and the capacity of the members of that collection. So these numbers can be in the future can be changed to have, I don't know, 4 more numbers, 5 more numbers. Put it in, no worries. You can append it, you can make it bigger, you can make it smaller if you want. It's working, yeah. So that's why it's used 99% of the time, because array is quite limited. And what array does, when you define a 5-membered array, it actually registers in the RAM, in your memory, it reserves 5, let's say, addresses next to each other. Could we say that slice, it's an array? An array, it's a cortege like in TypeScript. I'm not sure what cortege is, but the C# example or the Python one, I know that because also Python has arrays and lists. Okay, as a set. But set means that it cannot have a, let's say, duplicate value, right? Is that what is it? What is it? Or it's a different kind of set are we talking about here? Okay, well, it's not a cortege then, because arrays can have duplicate values as well as slices. I'm not sure if there's a set functionality in Go, to be honest, to have unique values only. But yeah, the best answer, the best example would be the Python list and arrays, or the C# arrays and lists. Basically, arrays are limited in terms of members that you can assign. You have to specify how many members you want to store in this array beforehand, before running your program. But with the slices and lists, you don't have to specify any kind of number of members. It's dynamic. You can add it, add any members anywhere in your program, and in the runtime while your program is running, it will make that operation perfectly. So as I was saying, when you define a 5-membered array, Go reserves in your memory. Okay, it's a tuple, so basically an tuple collection. Okay, got it. Well, you can actually edit the arrays, because you can change, for example, by using indexing, you can change the value resides in the, let's say, the first index. The only difference is just the member, length and capacity of the collection, okay? With arrays, you have a limitation. You have to define it beforehand. And if it's 5, it's 5. It will never be 6-membered or 7-membered, something like that, okay? But with the list, with the slices, you have that dynamic ability to change the member count. And as I was saying, array will reserve memory addresses next to each other with your defined, let's say, member count. Okay, so if it's 5, it will reserve 5 addresses in your memory, and then it will put these values in that memory address. With the slice, it's not working like that. Basically, it's a bit more complex in terms of the RAM management, but what it does when you try to add more than, let's say, the initial members. So for example, here we have 3 members of slice, but in the future, if we update this numbers list by adding 3 more items, it actually doubles the capacity. So for now, it has a 3 length and 3 capacity. That's how it starts as the first thing. And when you add 3 or 4, it doesn't matter. It will always double the capacity, even if you're adding 1. But if you're adding 3, it will also add more capacity, of course, because there's a little bit more complex algorithm behind how the slice actually works. But probably I can send some links in the documentation that I will create for you guys. But the fundamental thing is that it actually provides us a dynamic behavior of changing the collection. Okay, we're reaching the end, so let's finish it really fast. What it says to us, we cannot use numbers variable of type int as 5int because it's a slice and there's an array, okay? And we need to make a decision. So in a production environment, if you did such thing, and if you're, as you can see, this is failing, but this is passing. So what you should do, like if you change it, the code to make it work for this test, then this will fail. So you have basically two things here, two options. You should break the existing API by changing the argument to the sum function to be a slice rather than an array, which will actually break this test as well. And you have to update that test too, because here we're passing in an array, not a slice. Or you will create a new function called sum with slice, for example, so that it will retrieve a slice instead of an array. Well, this is a problem, but this is not a very big problem for us right now because we only have one place where we are using this function. We don't have any users who are using this sum function. So we can just safely go and just fix this to be a slice. When I do that, it will say to me, you were doing this wrong, as I just said to you, but I will just fix that by just removing that number and making this number is also a slice. And this should work. And then here we're going to run it. And as you can see, everything is okay. Well, also, one last thing I would like to go. As you can see here, we have two functions, a subset function that kind of does the same thing because like it just gets a number of number of numbers. We pass that into sum and then we expect something. Yeah, it's not that different in terms of, let's say, how it processes or something. Like even the, I don't know, inputs are same thing, and every test has a cost because this process will take some, let's say, computation power from your, let's say, machine that you will be deploying this to, for example. And in cloud computing, you pay for what you will run. Or, I don't know, if you're running it on your local machine, it's not very costly, but it can cost your time if it will take more time, for example. This is a very simple function, but if we say, if this was a very complex function, then to test the same thing 2 times again is not something we would actually do. And what we can use as a tool to see if our tests are, let's say, right on point and cost effective, we can write this with this special flag -cover, okay? I'm going to run all of the tests with this, let's say, flag. And I see here some coverage percentage, okay? This is learn Go with TDD is coming from hello and hello.testgo, all right? But don't worry about this. We're not interested in this part, this session. We're interested in all these 3 of them, especially the last one, because we have 2 subtests only in this package. And as you can see, this is coverage is 100%. That means I'm testing this sum functions as a whole, okay? Nothing is being missed. So I covered everything. I covered all possibilities that this sum function can return to me. Therefore, I'm actually good. But don't worry. And please also keep in mind, don't use this Go test cover something as a goal to make your test 100% coverage. This is not something that is expected from anyone. This tool actually just helps us to, gives us an idea, and it helps us to identify the areas of our code that it was not covered by the tests, okay? Therefore, don't please like feel yourself that you need to cover everything, etc., etc. But it's just a tool that will help us. I will show you why it's actually important to use this from time to time. I will just remove one of these, okay? The first one. I'm going to save it. Now it's a one function. I'm going to rerun the cover again. Look, it was not cached because we changed it. It ran, and the coverage is still the same. Then why should I have another subtest? Yeah, so this is something that you can actually look into. I'm going to keep the subtest here just for as a documentation purposes. But when you have 100% coverage, when you delete one of the subtests, then that means you should not have that one additional one. Okay. All right. Thank you so much. I will be ending it today here, but I have a request from you guys. If you could do that, it would be perfect. Could you guys go on mute or, I don't know, go on chat? Okay, I would like to take a screenshot of all of us, be on camera, because this will be basically used in the sharing platforms of our social media. If you cannot, it's okay, but for those who can, please do so. I would be very grateful for this. Thank you, Vladimir, Misha. Super, super. All right, I also stopped the recording here. So thank you for watching. Bye-bye, YouTube.